As you've noticed in chapter 2, we're spending a lot more time on linear functions, going a little bit deeper, but we're also pulling out a lot of review that we've already done in unit 1. So unit 2 really talks more about linear functions in a more general sense than just a little bit that we had in unit 1. So as we go through this section, like other ones, we do have a little bit of review, but I'm hoping like maybe it'll just affirm the knowledge that you already have. So part 1, I want to look at graphing linear functions. That's what the whole section's about. So for the first part, I want to look at plotting points. And so it says, just kind of a process for your instructions. You want to choose two values, your choice. Pick nice numbers though. Like I wouldn't pick crazy numbers that are off your graph. I wouldn't pick like crazy fractions. Pick two values, plug them into your function to find corresponding y values, and then plot those 2 points to connect. We are talking about linear functions, so they are straight lines, so 2 points are all I need. So I'm just going to come out here to the side, and you'll notice I kind of snipped this out of your homework and out of the book, because I want you to see the tools that you have. I want to clarify kind of how to plot this. So if I want to plot with 2 points, I'm going to pick two really nice values. I like to pick 0. And in this case, because I have a denominator of 5, I'm also going to pick 5 so that I'm not playing around with fractions and trying to graph an exact point at a fraction. But you can pick any 2 points you prefer. So I'm going to plug 0 in to this equation. So that would be 2/5 times 0 plus 2. That goes away. That's 0. So I just get a value of 2. So my ordered pair would be 0, 2. So I'm going to say 0, 2, and plot a point. And you're going to use this tool here to plot your point. Then we'll plug in 5. So that would be 2/5 times 5 plus 2. Just use your calculator to help you out with your fractions. I would enter with your fractions always in parentheses when you're using your calculator. So 2/5 times 5, what happens is those 5's cancel and you end up with 2 plus 2. Or if you typed it all in one swoop in your calculator, you get a value of 4. And so I'm going to go from 5 to positive 4. And I get an idea of what this line looks like. So I would use this tool here to plot your 2 points, and then come over and choose your line tool to connect the 2 points. If you feel like your graph is correct, but it's marking it wrong, just shoot me a message and say, hey, I'm working in the graphing linear functions homework, number 2. I'm pretty sure it's right, it's marking it wrong, and I can go in there and check and give you some hints on how to correct that so it grades it correctly. So plotting 2 points, no big deal. We already know so much information about linear functions, so you may have been thinking of another way to solve that. You were thinking, why didn't we just do y-intercept and slope? So part B, using y-intercept and slope. You want to first identify the y-intercept. If you don't already have it in that y equals mx plus b form, like we did from unit 1, then you want to be plugging in 0 for the x value and solve it out. So you can see in this equation here, it already has my y-intercept here of 5, again using that y equals mx plus b. But you could have come down here and said, okay, I'm looking for my y-intercept. What we know about finding intercepts is you plug 0 in for x and solve out. And you can see that also gives me a value of 5. So it just kind of depends on what form you're working with here. Part 2, identify your slope. So you'll notice my slope is the number next to my x because I'm in that y equals mx plus b form. So I've got my y-intercept, it's a 5. I've got my slope, it's a negative 2/3. Plot the y-intercept and then use the slope to find another point using rise over run. So y-intercepts, you're always going to start on your y-axis here. So I'm going to plot my 5, 1, 2, 3, 4, 5. Then from that point, I'm going to do rise over run. So I'm going to have to rise negative 2 and run 3. So I'm going to go down 2, 1, 2, and over 3. So this is my equation of y equals negative 2/3 x plus 5. Again, review. We've done intercepts. We've done slope. We've done plotting slope and y-intercepts. So just kind of reviewing as we're diving deeper into these linear functions. C, again, I noted, review. Let's remember how to find x-intercepts. It's the opposite of looking at your y-intercepts. So you're going to plug in 0 for the y and solve for the x variable. So here's an example. I want to find the x-intercept. So I already know my x-intercept is always going to have a y value of 0. So I'm plugging in 0 right here. I get 0 equal to negative 2x minus 6. Solve this out. So I'm going to divide both sides by negative 2. So x would give me negative 3. But it wants me to write it as an ordered pair. So pay attention to how it's telling you to fill in your answer. So I would just say negative 3, comma, 0. Lastly, we're going to be looking at part D. As we're talking about intercepts, let's review our horizontal and vertical lines. So remember, a horizontal line has a slope of 0, and the equation is just y equal to a constant, or if you like, you could say y equal to a number. A vertical line, the slope is undefined, so the equation is x equals to c, or a constant, or if you like, we could just say y equal xt equal to a number. Now I'll work two examples with you. It says, given the point 4, -1 and 0, -1 on a line, find the equation of the line. Well, first of all, if you got real familiar with those points in Unit 1, you'll notice that when you have the y values at the same, the equation is just y equal to -1. You're like, teacher, you went too quick. I didn't quite get that. Okay, let's take it back. x1, y1. x2, y2. Let's find the slope. Slope is equal to y2 minus y1 over x2 minus x1. So that gives me -1 minus -1 over 0 minus 4. That gives me 0 over -4, which is just 0. And we know that the slope of a horizontal line is 0. So you would come down here and say y equals mx plus b if you like. And you're just taking the long route here and you're like, okay, I'm going to have to find b. But you notice your 0 goes out. So again, we're back to y equal to a number. And that number is -1. So there's a couple of different routes that we could get to identify that this equation of the line would be y equals -1. Now in a graph, we see we have a horizontal line. So I see up here, horizontal line, the equation is going to be, excuse me, that's a vertical line. So the equation is, the slope is undefined. So the equation is going to be x equal to a number. You can see that all the x values, no matter what points I pick on here, are 7. So just by looking at a graph, I should be able to state that that equation is x equal to 7. Now lastly, let's review our parallel and perpendicular lines. Remember, parallel, you're going to have the same slopes. Perpendicular, you're going to have negative reciprocal slopes. So you're going to have to flip it and change the sign. So in the first example we're going to be looking at, given the function, identify which ones are parallel and which ones are perpendicular. Well, I'm going to start with parallel first. In looking at parallel, I see that these both have a slope of +2, so that means f of x is parallel to j of x. That's just kind of parallel notation. No one else is the same. Now, in order to find what it's perpendicular to, I have to go, okay, well, that has a slope of 2. So what would be perpendicular to that? That would be flip it, 1/2, and change the sign. So I'm looking for 1/2s and 2s and opposite signs. So for this, where are they perpendicular? Well, I'm going to have to use that 1/2, so g of x. If I flip it, that becomes 2. Change the sign, it becomes negative. So I'm looking at h of x. So that would be perpendicular to h of x. So it's just going further into what we already know about parallel and perpendicular. Last example, because you will have to create some functions. Find a line parallel, so you need to be thinking same slopes to the graph 3x plus 6 that passes through the point 3, 0. So this tells me that from this information, I want a slope of 3. From here, I have an x and y value. So I could just say y minus y1 equal to m of x minus x1 and solve it out. Again, this problem is not new. It was probably on your unit exam for 1. So I'm going to say y minus y1, which is 0, equals 3 of x minus 1. Distribute. Y minus 0 is just 0. 3x minus 3. So this is an equation parallel to this one, but going through the point 3, 0. Again, this lecture even went a little bit quicker as well too, because a lot of it was just rehashing and going into more details of what we already did in Unit 1. As always, if you have any questions along the way, feel free to contact me.